Fomenko's work attempts to resolve what he sees as a fundamental incompatibility between consensual history and modern astronomy. This creates a direct conflict between the established historical narrative and the unyielding laws of physics and mathematics. The tension is captured in a prescient warning from St. Augustine, highlighted in the book's introductory materials. Be wary of mathematicians, particularly when they speak the truth. Fomenko's investigation into this conflict did not begin with a broad assault on history, but with a single, perplexing astronomical anomaly that could not be explained by modern science: a strange leap in the motion of the moon. The story of this chronological challenge begins not in a dusty archive, but as an unexpected byproduct of the Cold War. The intense Russian-American competition to explore the moon fueled meticulous research into celestial mechanics at institutions like NASA. It was in this context that scientists sought to refine their understanding of the long-term dynamics of the Earth-Moon system, using a value known as the lunar acceleration parameter, or d double prime. This parameter is calculated by analyzing the precise timing and location of solar and lunar eclipses recorded throughout history. In the 1970s, Robert R. Newton, an astrophysicist at NASA, used the conventionally accepted dates for ancient eclipses to calculate how d behaved over time. He discovered something inexplicable: a drastic drop in the parameter's value, resulting in a mysterious leap of an entire numeric order between the 7th and 13th centuries AD. This anomaly was so significant that it defied known physics. As Newton himself concluded, such changes in the behavior of d, and such rates of these changes, cannot be explained by modern geophysical theories. Faced with this puzzle, the scientific community proposed the existence of mysterious non-gravitational forces to account for the leap. Fomenko, however, approached the problem from a different angle. Instead of inventing new forces to make the astronomy fit the history, he posed a simpler, more radical question: what if the historical dates themselves were wrong? Following the groundwork laid by Russian scientist N.A. Morozov, Fomenko undertook an unprejudiced astronomical dating of eclipses mentioned in ancient texts. Instead of assuming the conventional time frame was correct, his team searched for astronomical matches across the entire historical record. The result was dramatic. When the ancient dates for eclipses were discarded and replaced with newly calculated medieval dates, the mysterious leap in the d parameter vanished. The graph of d transformed into an even, practically horizontal line. This result was profound. A horizontal d graph is precisely what one would expect from a stable Earth-Moon system governed by known gravitational laws. In Fomenko's view, his redating didn't just fix a historical problem. It restored order and predictability to celestial mechanics, thus elegantly solving the anomaly that had stumped Robert Newton. The Thucydides triad serves as a powerful example of this effect. The conventional dating problem. The ancient Greek historian Thucydides, in his History of the Peloponnesian War, describes 3 eclipses, 2 solar and 1 lunar. The conventional dates assigned to these events by the chronologer Petavius are 431 BC, 424 BC, and 413 BC. However, this dating creates a major contradiction. Thucydides explicitly describes the first eclipse as total, stating that several stars appeared. But modern astronomical calculations show the eclipse of August 3rd, 431 BC, was only an annular, partial eclipse in Athens, making it impossible to see stars. Historians have been forced to explain this away as rhetorical embellishment. The new chronology solution. When Fomenko's team searched the entire historical timeline for a triad of eclipses matching all of Thucydides' detailed conditions, they found 2 precise solutions, both in the Middle Ages. The table below contrasts the flawed conventional solution with the precise astronomical solutions proposed by the new chronology. Table. This transfer effect, where detailed descriptions of ancient astronomical events find their only perfect match in the Middle Ages, is not unique to Thucydides. According to Fomenko, it applies to virtually all detailed eclipse descriptions from antiquity, including those found in the works of the Roman historian Titus Livy. This pattern of redating extends to another form of astronomical record: horoscopes. In astronomy, a horoscope is not a daily prediction, but a precise map of the heavens at a specific moment in time. It records the arrangement of the 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn, within the 12 constellations of the zodiac. Because planetary orbits are well understood, these configurations are unique and can be used to calculate an exact date. Among the most famous horoscopes from the ancient world are the Egyptian zodiacs carved into the ceiling of the temple at Dendera. Conventionally, these carvings are dated to the 1st century BC or 1st century AD. However, repeated attempts by astronomers in the 19th and 20th centuries to find an astronomical configuration matching the zodiacs in that era failed. The new chronology offered a breakthrough by extending the search for solutions into the Middle Ages and beyond. In 2001, Fomenko and his colleague, G.V. Nosovsky, calculated final precise datings for several key Egyptian zodiacs. The round zodiac of Dendera, morning of the 20th of March, 1185. AD. The long zodiac of Dendera, 22nd to 26th. April, 1168. AD. The Brugsch horoscope, from a coffin. The horoscope of demotic subscripts was dated to the 18th of November, 1861. AD. The implications of this evidence are profound. If these monumental stone carvings, which are highly unlikely to be forgeries, contain horoscopes pointing to the 12th century, or even the 19th century, it fundamentally undermines the ancient dating of the temples themselves. By extension, it calls into question the entire conventional timeline of Egyptian civilization. This evidence became the subject of intense academic dispute, illustrating the deep methodological chasm between Fomenko's camp and the mainstream. Proponents of the new chronology point to refutation attempts by critics like E.S. Golubtsova and Y.A. Zavenyagin, accusing them of deliberately rigging their computer analysis. Fomenko's camp alleges that by omitting the constellation of Aries from the input data, the critics made it impossible for their own software to find the medieval solution, effectively forcing a negative result from the start. The argument presented in Astronomy Versus. History is a direct and profound challenge to our understanding of the past. Anatoly Fomenko puts forth a case, grounded in what he claims are irrefutable astronomical calculations, that our entire conception of ancient history is built upon a flawed and artificially extended timeline created in the 16th to 17th centuries. He and his colleagues have issued a challenge to the historical establishment. They are ready to retract their theory if, and only if, methods like radiocarbon dating can pass rigorous black box tests, or if their astronomical results can be definitively refuted. The new chronology forces us to confront fundamental questions about how we know what we know about the past. Is it a meticulously constructed scientific theory that exposes a centuries-old error, or is it an elaborate historical fiction built on the misuse of statistical and astronomical data? It serves as a stark reminder of the power inherent in controlling the narrative of the past, a sentiment powerfully expressed by George Orwell. Who controls the past controls the future. Who controls the present controls the past.